I'm going to use this figure, which represents figure 7.4 on page 234 of the book, to discuss type 1 and type 2 errors and alpha and beta. This figure was constructed by using this information on the left here: sample size of 100, standard deviation of 10, a mean value of 48, a standard error of 1, and the alternative mean information is not yet useful. The figure was constructed using the norm_dist function, which actually produces a normal distribution, but this distribution, as shown, would be a t-distribution with 99 degrees of freedom. It would be slightly flatter than a true normal distribution. To discuss type 1 and type 2 error and alpha and beta, we'll begin with the notion of alpha, which is the type 1 error. If we began with the initial hypothesis that the true average height of 6-year-old boys was 48 inches, and if in fact the true average height of 6-year-old boys was 48 inches, any sample of 100 boys that we drew from the population in which the true mean value was 48 inches would lie within this blue distribution. For example, we might find a sample where the average was 48.25 inches, which is approximately what this blue line shows. Or we might find a sample which was 46.75 inches, which is what this blue line shows. Or we might find a sample which was 50.5 inches, which is what this very short blue line shows. This red line is the upper 95% limit for the hypothesis of 48 inches. This red line is the lower 95% limit for the hypothesis of 48 inches. These two lines are set at approximately 2 standard errors above the mean and 2 standard errors below the mean, 46 inches and 50 inches. If we draw one sample from the population in which the true mean value is 48 inches, we have the possibility of making type 1 error, which is the possibility of finding a sample that lies either on this side of this red line or on this side of this red line. If we got a sample that lay in the range either above the upper red line or below the lower red line, we would reject the null hypothesis of 48 inches. But we have a 5% chance of getting such a sample. That is type 1 error. That is alpha. If we were to set alpha at some other level, say for example at 0.01, that would require that we move these red lines out 3 standard deviations approximately to here and here. In that case, we have only a 1% chance of making type 1 error. Nevertheless, there is always some chance of making type 1 error. We, as the researcher, decide what type 1 error will be by the limits that we set.